All right, in this movie we'd like to talk about concurrent forces, and we've kind of really talked about these things before. Concurrent vectors are any vectors that are working on the same point. So if I have two concurrent forces that are pulling on the same point, let's draw in a force working up this way, and then another force pulling over like this way. And so let's say that this force here is like a 10 Newton force, 10 newtons, and this force here is a 15 Newton force. And let's say that there was 20 degrees between them, 20 degrees. This is the vector going out this way. So we have two forces. These are concurrent forces, which means they're both pulling, working on the same point right here. And what we want to do is we want to find the resultant of these two forces. Well, if we want to find the result of these two forces, to add them together vectorially, you always add tail head, tail head. So I'm either going to take this force and put it on here. So I'm either going to take, I could take this 15 Newton force and redraw it, right, the tail of it onto there, like that. Or I could take this 10 Newton force and I could put it onto here. Either way, it doesn't really matter. We're gonna end up, if we do it one way and then we do it the other way, we're gonna end up with a parallelogram. And so the resultant force is going to be from the tail of the first to the head of the last. So I can just make a resultant force from here on up to there. And so there's kind of two ways to do this. I can let's redo this again. Let's take the let's take this 10 Newton force and let's add it on here, right there. And so this is the 10 Newton force. And if this was 20 degrees, then I could draw a little dotted line here. That would be 20 degrees also. So this angle in here would be 180 minus 20. This would be 160 degrees. And I could draw my resultant here, like so. And I can just use the law of cosines to figure out the magnitude of this resultant. So it would be 15, if you remember, 15 squared plus 10 squared minus 2 times 15 times 10 times the cosine of the angle between them, 160. And then it would be the square root of this whole thing. That would be my resultant side. And if you do that whole thing out on the calculator, you'll get a magnitude of 24.6 newtons. That's the cosine method. The other method on this is to do I hat, j hat, and maybe we should just review that real quick. This here was the cosine method. If we redo this here, let's try this again here. Let's make my 15 Newton vector here, and I'll make my 10 Newton vector up like so. 10 newtons and 15 newtons, and we have 20 degrees here. And if we don't want to rewrite these over again, then we can just write I hats and j hats for this. So the 15 Newton force is pretty easy. It's going to have a 15 I hat, and it's not going to have any vertical vector at all. So it's going to be 0 j hat. And then the 10 Newton one, I can draw a I could draw it over and up, or I could draw it a up like so and an over. And if I do that, if I go up and over, now I'm going to have to realize that this here isn't 20. This is going to be 70 degrees here. And I could get this opposite side, which would be the resultant, 10 newtons, times the sine of 70. That's the opposite side. And this one here would be 10 newtons times the cosine of 70, because that's the adjacent side. And if we figure those out, then we'd get something like 9.39 I hat and our j hat would be like 3.42 j hat for the this vector here. So j hats are vertical and our I hats are horizontal. And so if I take those, I can just add those together, and I get 24.39 I hat, and I get plus 3.42 j hat, and that means I'm going to go over 24.39 I hat, and I'm going to go up 3.42 j hat, and I can just do Pythagorean's theorem here to get this one. So it'd be 24.39 squared plus 3.42 squared, and I take the square root of that whole thing, and I'll get my resultant, which if you do it that way, you still are going to get the exact same answer, 24.6 newtons. So it's just both ways there. You can do I hat, j hat. Some people like this method a little bit better, and some people just like the law of cosines. If you have more than two vectors, you're going to want to use I hat, j hat. It's just a lot easier. If you have only two vectors, then probably you're going to want to use this law of cosines up here. Now that's just finding the magnitude, by the way. We also can figure out, where is this this vector? Here's my resultant vector. What is the angle? Where is this vector at? And in that case, we usually use the law of sines. So I would have the sine of 160 over 24.6, and that would equal the sine of the angle that I'm looking at over the opposite side, 10 newtons. And you just do a little cross multiplying here, and an inverse sine, and this comes out to be about like 8 degrees, I think, or so. 8 degrees. So you could say 24.6 newtons at 8 degrees north of east, or we can always go from all the way from north, so it'd be like 82 degrees. You could just say at. You'd say 24.6 newtons at 82 degrees. And as long as we just say the degrees only, that means we're going to assume that it's from north going around in this direction. So we just say at 82 degrees, or we could say 8 degrees north of east. But normally we'll have to use the I was just figuring out the magnitude here, but a lot of times you have to figure out what the direction is for the force too. That's just kind of adding vectors, and this time we're talking about forces. So these are examples of concurrent forces. In the next video, we'll use the same problem, and we'll talk about figuring out the equilibrant to bring this all in equilibrium. Because right now we have a resultant force, and according to Newton's second law, F equals ma. So if you have a force, if you have a net force in a certain direction, like we do right here, going along this way, then that means this object right here is going to be accelerating in that direction. Well, what if I don't want it to be accelerating? Well, in that case, I'll need to figure out what force should I put on here so that it does not accelerate. And we'll look at that in the next video. So hopefully that helps you a little bit understand concurrent forces.